Today we're going to go over a few more conversions. So grams to kilograms and kilograms to grams. Now when we're talking about metric conversions, we are basically just moving the decimal point because they are all multiples of 10 is the conversion factor, which I will show you exactly what that means. So basically for conversions, for any conversions, metric or otherwise, the most important thing is if you're going from a bigger unit to smaller unit, it's the opposite of what you would expect, and you are going to multiply. Okay? And then from smaller unit to bigger unit, you are going to have to divide. Now typically, as I've said before, with numbers, if you're going from a bigger number to a smaller number, it's because you're dividing. And if you're going from a smaller number to a bigger number, you're dividing. You're multiplying. But in this case, it's the opposite of what you would expect. Because obviously if the unit is smaller, that means there's going to be more of the smaller unit in a set, in this case, weight or distance or volume of liquid, right? So the first thing we have to figure out is, first of all, what is the conversion rate of grams to kilograms? So the answer for that is, we have to know this, but 1,000 grams, and kilo just means 1,000. So 1,000 grams equals 1 kilogram. Okay? So kg is kilogram. Grams, you can usually just put a G. So 1,000 grams equals 1 kilogram. So the conversion rate is 1,000. So that means we're either multiplying or dividing by 1,000. And to do that, all we're doing is moving the decimal, okay, which I will show. So first thing, we have 96,000 grams. How many grams? How many kilograms is that? So we're going from so if there's 1,000 grams in 1 kilogram, this is another way that conversions are opposite of what you would expect. Which one's bigger, 1,000 or 1? Obviously 1,000 is bigger, but if 1,000 grams are in 1 kilogram, then a kilogram is 1,000 times the size of a gram, right? So there's, a ton is 2,000 pounds. So what's bigger, a pound or a ton? Obviously a ton is, right? So this is the same thing. So this is another way that conversions are the opposite of what you would expect. So we have 1,000 grams equals 1 kilogram. So if we're going from a smaller unit to a bigger unit, right, from grams to kilograms, we have to divide. And it's always a good idea when you're doing this work to just put this on your scrap sheet, put it on the test, put it on your homework. Just this right here is so important, and it's always good to just double check back, because a lot of times it's easy to really get messed up on it. Like, sometimes I'll even have to think about it a little bit. So it's always good to write this, and always remember that it's the opposite of what you would expect. And when you're comparing them, the number that has 1 in it is always going to be the biggest, and then the other number that's more than 1 is going to be the conversion rate, right? So anyway, so we are going to divide by 1,000, and all we're doing when we divide by 1,000 is moving the decimal place the amount of zeros. So the decimal place of 96,000 is always at the end It's right after the ones column. So if there is no decimal place in a whole number, then the decimal place is right after the ones column, and then we're just moving it 3 times to the left. 1, 2, 3. And then the decimal place would be here. So the answer would be 96 kilograms, because it would be 96.000, but you can drop the decimal place and the .000 because that doesn't change the value, and then it just becomes 96. So it's the same thing here. We're just moving the decimal place 3 times, right, from grams to kilograms. So this one would be 47. Now we have 94 kilos, so we're actually going to multiply. And we're actually doing the same thing here. So we're going to do 1, 2, 3. And then you think, wait a minute, there are no numbers here. So what am I doing here? Each of these loops you have to put a 0. So it ends up being 94,000. Now, if you're multiplying, okay, a whole number by a multiple of 10, you can just add the zeros to the whole number, right? So there's 3 zeros in 1,000, so you can just add 3 zeros to 94. But the problem with that is if you run into a decimal like 9.4, okay? So now, if this was 9.4 kilograms, okay, and then I were to say, oh, 9.4 times 1,000, I'm just going to add 3 zeros at the end. If you add 3 zeros after the decimal point, it doesn't change the value. 9.4 is the same as 9.4000. So what we're doing is we actually have to move the decimal place, right? So we're 9.4 times 1,000 would be 1, 2, 3. Okay, so, and as I said, if there's no number here, you have to put the zeros here. So it would be 9,400. Now, if it was 9.4 grams equals how many kilograms, right? 9.4 grams equals how many kilograms, okay? We're moving the decimal place in the other direction. So we're going 1, 2, 3. Okay? And the decimal is right here. And as I said, each time you have you don't have a number and you move the decimal place, you have to put a 0 there. So 9.4 grams would actually be 0.0094, or 94 ten-thousandths is actually what it would be. Alright, so I think this, just basically knowing how to move the decimal. And we're doing it with 3 zeros because it's 1,000 grams in a kilogram. Now, if it was 100, if we're talking about centimeters, 100 centimeters equals 1 meter, then we would be moving the decimal place only twice, right? So 200 centimeters equals how many meters? It would be going from a smaller to a bigger, so we're going to divide by 100, and we're just moving the decimal place 2 times, and it would be equals 2 meters. Okay? So that should explain this. 1, 2, 3, right? Grams to kilograms is dividing, so that's 63. 24 kilograms, we're just multiplying by 1,000, so 0, 0, 0. We could go through all of these, but I think this kind of gives a good explanation on it. So hopefully that's helpful.